Okay, these are some more problems from section 9.5. This is number 45, so this is our series. The square root of n all times x to the n over 3 to the n power, so we'll check for absolute convergence using the ratio test. So this is our ratio test. We take the limit, and this is every time we see an n, we put an n plus 1, so square root of n plus 1, absolute value of x to the n plus 1, 3 to the n plus 1, and then the reciprocal, this is going to be 3 to the n because we're dividing by this, so we'll just multiply by the reciprocal. 3 to the n all over square root of n, absolute value of x to the n, so that's the same thing. Then we'll break this up again, as we normally do, x to the n, and x, and then 3 to the n, 3. And then we have these, so we can cancel the 3 to the n's and the x to the n's, and this is my limit. And this limit will approach, we can, like I said, as n approaches infinity, this becomes just the square root of n over the square root of n, which is 1. So this is our ratio, so we know that that's going to converge, that's going to be equal to L, and that's going to converge absolutely, because we checked absolute convergence when L is less than 1, which means it also converges. So when the absolute value of x over 3, which is equal to L, is less than 1, we can multiply both sides by 3. The absolute value of x is less than 3. So this is my interval of absolute convergence, all right? And it's also converges for this interval, but we want to check the endpoints and see what's going on. So we'll check the endpoints. And at x equals -3, I can put -3 into my series, -3 to the n. And I kind of simplified over here so you can see what's going on. Here we go. So I have -3 to the n, which is the same thing as -1 to the n times 3 to the n, so those 3 to the n's cancel, and I've got this. Those cancel, I put this in front. And then we can check this by the nth term test. When you take a look at this, it's obvious that this is not going to equal to 0. The limit as n approaches infinity, this does not equal 0. It oscillates, so it doesn't exist. All right, it must equal to 0 for it to. If it converges, it equals 0. The limit equals 0 if it converges. So therefore, if it doesn't equal 0, it can't converge. So it diverges by the nth term test. Remember, we use a contrapositive there to verify that logically. And then we try 3. If I put 3 in here, this is oops. This is the 3 to the n. Let me just double check this. Yeah, 3 to the n, pardon me. There's my 3 to the n, and then those just cancel. That's just 3 to the n over 3 to the n, so I just have this. And then the limit of that is infinity, so that also diverges. The limit as n approaches infinity of my nth term does not equal 0, actually equals infinity, which is undefined also, doesn't exist either way. Now think about that. So that diverges. So both my endpoints diverge, so I don't have to worry about those. So my interval of convergence is basically -3 to 3, which is the absolute interval of convergence. But remember, if it converges absolutely, it converges. So this is my interval of convergence, and that's also my interval of absolute convergence, or those are the values which it converges absolutely. So therefore, I have no values of conditional convergence. Okay? So that's not too bad. Hopefully you can follow all that. You can always slow this down if I'm going fast. And let's take a look at 46. And 46 is a little bit different, but not too much. Okay, we've got the n factorial, x minus 4 to the n. We're again going to first use the ratio test to check for absolute convergence. So this is the limit, and a to the n plus 1 over a to the n again. So I'm just going to take this. So n plus 1 factorial, x minus 4, the absolute value to n plus 1. And then I'll just put it right over that. Since it's not a fraction, it'll be easy to write in this form. So that's n factorial, x minus 4 to the n. And then I'll separate this up, n plus 1 times n factorial, and then this is x to the minus 4 to the n, x minus 4, and again we're using absolute values there on the x's, over the n factorial, and x minus 4 to the n, so the n factorials cancel, x minus 4 to the n cancel, and I have this, and that equals L. Now, what happens is this is going to go to infinity, so there's a couple ways to look at it. This is one way to look at it, and then when x equals 4, this is equal to 0, so L is less than 1, and when x is not equal to 4, this is going to be infinity times that, which will be infinity, which means L is greater than 1. Remember, series always converges at its center. So it converges only at x equals 4. and it converges absolutely at x equals 4, and no values of conditional convergence. Okay? So I hope that makes sense. Oh, sorry, let me get this down.